We're continuing our conversion of a Master Replicas 2006 Darth Maul lightsaber. This section is part 2 on assembling the new components back into our hilt. We're going to start with soldering all of the wiring and components together. You can see that I have my soldering station set up, my soldering iron, a brass wire cleaner, and my helping hand station here, which is pretty much essential for holding everything together, freeing your hands up to manage the solder and the soldering iron. My station has a nice little magnifying glass here that for today's purposes we're actually going to remove. It's not a critical item for doing this, and it'll just get in the way of the camera, so we'll just set it to the side for today. Alright, before we get anywhere near starting the soldering, it's always a good idea to walk through the wiring just mentally to make sure that you don't make a mistake or get yourself too far and have to undo it. So I've already pre-stripped all of the wires that I've got available. So starting with our wiring harness, near the top we've actually got two wires, one gray and one purple, that come out of one side of our wiring harness. The gray wire actually goes to our clash sensor, and then it's got a blue wire coming off of that. Basically what's going to happen is that blue and purple wire is my positive. Okay, so those ones are going to go together, and they're going to go through our resistor. So the resistor is going to match our voltage between our battery pack and our LED, so we're going to run it through there. From there, I have just a small length of stranded wire, in this case 22 gauge stranded wire. Rather than go out and buy specifically stranded wire, one of the things I did as a bit of a cheat is I had, if you've got an old adapter, DC adapter hanging around, that you don't need to use anymore. It's a decent size. I actually just clipped part of the wire off of that one. It was 22 gauge stranded wire, which was perfect. And then from there I coated one of them with some electrical tape, red for positive, and left the other one black for negative. So my positive is going to come out of my resistor, and it's going to be wired to the positive side of my LED, clearly labeled on there. From there, I've got my other piece of stranded cable that I salvaged off that adapter is going to come off of the negative side of the LED, and it will eventually attach to all of the remaining colored wires coming out of my harness. So there's a whole bunch of them there. I think looks like five wires, and I've stripped and twisted all of those together, and that will connect to the negative side, and that will complete the entire circuit. I've also got heat shrink available to me, a couple of different sizes. I've got some 3/32 and some 3/16. And make sure that you plan ahead and get your heat shrink on first. Slide it up the wire out of the way, and then do your soldering so that you can then slide that back into place and then heat it up and shrink it onto the cable. All right. So with that, it's time to actually start our soldering. I'm not going to show you all of the soldering. I think that'd be far too boring. So I'll get some of it done, but I'll show you a little bit of the soldering in a couple of components here, so you can see how that all came together. Alright, so at this point I've actually already soldered the positive wire to the positive side of my LED here. And we're going to take a moment just to show you the soldering to the negative side. I've already done some pre-tinning, very helpful when you're actually doing your work, is to take the solder and melt some of it onto both components. Makes it a lot easier to basically apply the soldering iron afterwards and kind of have it just suck together. So I've pre-tinned both sides of that already, so now it's just a matter of using my alligator clips to very firmly, we may need to tighten this up a bit here, to get a fairly firm connection between the wires and the pad that I'm going to solder it into. One thing to be very careful of, just make note of, make sure that the holes that you're going to put your wires through are completely opposite from each other. The lens holder actually fits into two side-by-side holes on either end, so in order to make that work, you actually have to make sure that your positive and your negative wires go down through the holes on opposite sides from each other. So I've made sure that I've positioned that in there. Okay, so now I've got my soldering iron just to basically touch and heat this up, and it's going to heat up the solder that was pre-tinned on my negative cable as well as the solder that's on the negative plate on the LED. And if done correctly and I've got it hot enough, basically all we have to do is heat it up, and it will basically melt together, suck together, and we will get a very, very good connection there. Okay, so I'm just going to work on that. Might have to work on that for a few seconds, but you get the idea. Pre-tin it and then essentially melt it together. So next up, now that we've actually got that all soldered together, positive and negative side, we're going to attach it now to our heatsink by means of thermal tape. So this was something I purchased as part of the supplies. Basically it's sticky on both sides, so I'm going to pry up one part of it here off of the clear. Take the whole thing off. And we will position it, lining up the holes appropriately to position it right onto the heatsink. Make sure you do it on the opposite side from, you can see that there is a slot in here that will be used later to screw that into the blade holder, so make sure that your thermal tape goes on the opposite side. We'll then peel off a bit of a protective layer there. On top of that, to peel that off. And so we're left with just a sticky side. And so we will take our LED, feed the wires through on either side, and basically firmly stick that down. Okay? So I'll give it a good firm tug all the way around. And basically that's now very secure for that one, and eventually that will screw in. Now, I'm a bit obsessive about testing things as I go along, so just going to prop that up there. I've got my positive and negative side there, and I'm just going to very briefly grab my original parts, plug the wiring harness back in to that. Make sure you get it going the right way here. Ooh. There we go. Wiring harness goes back in. And we'll put the battery pack on it. I'm going to make a little bit of a loud sound. And then basically I'm going to touch the wires to my LED. So hopefully you can see that. You can see it briefly light up. But when it lit up there, alright, so my LED is actually working there. So I'm going to set that aside, and it's looking all good. Alright, so I'm just going to continue on with the soldering. I'm going to solder in the resistor, making sure I put my heat shrink on first, and then solder up the rest of the wires together and finish that all up. Alright, we're pretty much done. Most of it's actually all wired up. We've got one last connection to make here. I've pre-tinned the wires. You can see I've got my heat shrink on. In this case it's going to double up because we've got one wire on one side and 5 on the other. Basically take our helping hands, move it into position, and apply the heat to the joint and get that pre-tinned solder basically to melt together. Giving ourselves a nice little connection there. A little bit more on this side. Didn't kind of work the way I wanted to. Sometimes takes a little patience to get the soldering. I'm obviously not the best, so if you're a great solderer, you're probably looking at this and seeing lots of opportunities for improvement, but I'm learning as we go here. Okay, so we got that together. We'll pull the heat shrink and that will be done. Okay, so now that we got all our wiring done, all our nice heat shrink is all put together, resistors on, it's all good. I'm going to point the LED down, turn the switch on, grab my battery pack, and we'll do a test to make sure everything's good. So that's excellent. So just another little bit of a tip for you. If you've got a soldering joint, you want a little bit more mechanical strength to it to make sure it's good. You know, these other ones we've got heat shrink on and they suck together, it's pretty good, but these ones on the LED, you might just try a little bit of hot glue. It doesn't take much to kind of, you know, glue in where that cable goes down through the hole. Might be subject to some stresses. It's got an easy enough thing to take a hot glue gun and just put a little dab of hot glue on it. There we go. Boom. And a little bit of hot glue won't interfere at all with screwing it in or with the lens holder. Just make sure you're putting it on the side for the screen. Make sure you're putting it on the side where the cable goes through, and that will be fine. Alright, next step on our path is we're going to take the lens holder and our lens. We've got a little notch on it that you can fit into the side there, a little notch cut out. Basically it snaps into place right into the lens holder, and then the lens holder itself has 4 little feet on it that actually fit into the 4 open feet that are on the LED. That's why it was so important for us to make sure that the cables went down, or the wires went down on opposite sides. So basically you can just find that position, and it essentially just snaps in there very snugly. Alright, nice job there. We've now got our conversion kit, our blade holder, and essentially that heatsink with the lens on it is going to screw right in. Okay, it's got a little slot in it for a slotted screwdriver. It'll help you do that. So basically we can screw that in and it will screw up nice and tight. And there's a little lip inside that the lens holder will eventually hit, and that will hold the lens snugly in place. You can feel it there, so we don't want to over tighten. Get it nice and snug. And basically there we are, is the lens and lens holder snug against that lip, screwed all the way in. So on the Darth Maul conversion, one of the challenges we've got is there's not a lot of space for wires. Basically you only have the space that the heatsink is inserted into the blade holder. So we need to do something in particular with our clash sensor here. So one of the tips that TCS has on their tutorial is to take your circuit board holder and just drill a hole the size of the sensor right into it there. There used to be a pin there, and make sure you're doing it on the side. Take a peek in through the holes. Make sure you're doing it on the side where the circuit board is not, so you're not drilling through the circuit board. But right close to the edge, go ahead and do that. And what you're going to do is we're going to take the clash sensor and we're actually going to insert it into there. And then basically with a little bit of hot glue, we're going to hold that whole circuit board in position and then wrap the cables around as we need to so that we can get a fit. Okay, so I'm just going to do that off camera, is just take my hot glue gun and just do a little bit of work here to get that moving into position. And so basically once I've hot glued that back into place, takes a little bit of maneuvering to get all the wires in there. Might have to, you know, very carefully wrap them around, fold the resistor over and tape that up. But then the blade holder basically needs to fit down snugly against that piece. And I've just run a couple of rows of Scotch tape there to keep it in position. Since I'm obsessed about testing at every step to make sure I haven't broken anything, I'm going to pop the battery pack on temporarily, flip the on switch, and yes indeed we are still very much in action. Before we get to inserting the electronics and the blade holder back into the hilt, I want to make one comment about the blade retention screw. As you can see here, as I'm looking at the blade holder section of the conversion kit, there is no pre-drilled screw hole for a blade retention screw, and that's because there's actually no pre-drilled hole on the hilt that could automatically be used. So you're going to have to create and drill your own, and that can be a little bit tricky. You're going to want a good drill, especially one that has a controllable speed, and obviously you'll need a tapping bit to be able to do that for whatever size screw you actually want to. I'm going to be using a number 8 32 thread count screw that will go into there. But before we get that far, I want to talk a little bit about a couple of things to be aware of when you're getting to the place where you want to do your screw. First off is I'm going to unscrew again, as we did in the disassembly. I want to unscrew the part of the emitter at the top. And just make a comment that you probably don't want to be drilling your hole in a place where you're going to end up going through these threads. The extra thickness of the material, as well as just making sure that it can screw and unscrew if you ever need to get at things. So we need to know and understand how far that actually goes in before I actually screw something for that. So I'm going to screw that back in. The second thing, of course, to remember is while this is full length, at some point in here we actually have the little lip, and then the actual LED and lens is actually in the bottom portion of this. So we need to actually drill it up higher than that, preferably as high as we actually can, or as close to the end as we can, so that we actually get a good hold on the screw. So what does that actually mean? It doesn't leave you with much room. Basically, those screw threads come down to within about 1/8 of an inch, a little bit more than 1/8 of an inch of this first aluminum. So they're still in the black. Stops right about there is where the thread count comes, or the thread length comes, and there's a little bit of black left. The lip on the blade holder itself, or the LED, comes basically to the end of this thicker aluminum section here. So you can't drill anything in here because you'd be drilling into the lens. So basically you're left with an area about the width of this aluminum strip and the black on either side of it. So we want to be as high as possible. So essentially you need a screw hole that's just barely in the black, right up here on the top, basically touching. Your drill bit's going to touch right to that aluminum colored part, and you're going to drill through there. In the hilt, you just need an open hole on there initially, and then you'll be able to use your tapping bit once the electronics are reinserted in order to be able to go in there, and then you can put your machine screw in there. And either paint it black. You could go a little bit, if you're going aluminum, you could actually drill through this initial part here, but of course it's a little thicker. So I'm going through the thinnest part, easiest part that I can do. That will be this little bit of black here that'll get me away from the threads, but still high enough that I can actually be useful as a blade retention screw. Alright, so I'm going to go away and do that. Then we're going to talk about the getting the electronics and the blade holder inserted back into the hilt. Okay, so I've had the opportunity to drill a hole. You can see it just right there. If you're wondering what kind of drill bit or what size drill bit, 11/64 is what it takes to drill a hole that a number 8 32 machine screw can fit into cleanly. It is a little bit high, as it turned out, and you might be able to just see it there. You can see there that it did actually nick a little bit of the threaded portion. Didn't make it all the way to the threads, so it does screw on still without any real difficulty, if I can find the right spot. So you tighten that up, and it still actually works just fine. So cleaned up all the threads, make sure I got all the little bits, little filings out of there, and we go. And now it's time to actually insert the electronics back into it. Basically we're going to work from the pommel forward and push it in. The key to all of this is getting this piece here, basically that circle where the switch actually is, to line up with the hole that we actually have for the switch. There's a number of O-rings internal in there that you're going to have to push past at the end there, so it might be a little bit tough. You'll feel like you're breaking it, but you may have to be, firmly push on it. To help you out, one of the biggest things that you can do is you can see these two knobs right here. If you line them up as you're inserting with the hole here and the switch, the round switch there, basically it all lines up. So that should actually help you as you go, is trying to line that up as you go, and then make sure that you are pushing as closely as possible in a straight line. Got some resistance there, so that's the first O-ring, and we keep pushing on that one, moving it up. You may get to a certain point where it may actually be easier to put the battery pack in, and then again continue to push on to that one. You may again periodically feel the resistance. And then we get to the end. At the end, the last bit of resistance is there is actually a clear O-ring right at the end that's going to hold the blade secure. So I got to sometimes be a little bit forceful with that to get that in place. But eventually it will get there and cover that one up. And then you can see we're pretty close. Hopefully you can see. I don't know if the light actually helps you, but we're pretty close on there. Might have to do a little bit of jiggling. Very, very carefully with a flat bladed screw to get that in place. But basically, once we've got that all lined up and centered on the hole, we can start in again with screwing back in our switches. So just a little tip if you're working on getting that lined up. You saw me use a little screwdriver in there to kind of move it. I wouldn't do a lot of that. Don't put a lot of pressure. You wouldn't want any of that plastic to break off. So if it's more than, you know, a half a millimeter off, you may be better off again backing it out a little bit. And it's actually pretty simple if you do back it off an inch or two, that you may be able to use the battery pack to just slightly twist it just a little bit and push it back in, and then you'll get something very, very nice in there. The O-rings keep it nice and snug, so again, we don't have a lot of set screws on this type of lightsaber to keep it in place. The internal O-rings do a pretty good job of that themselves. Alright, so back to our baggie we had when we did disassembly. We're going back here and we are going to now reassemble everything. Okay, so first thing we've got, easiest thing we've got is we did have a little aluminum knurled string with our knob with a washer on that one. So that's easy enough just to put back into place. We're going to fit the washer on there and that just screws right back into place very, very, very easily. Now we're going to work in reverse to get the power switch back into place. This one actually may take a little bit of care. You'll remember that we had a nice little kind of brass colored spacer that actually went between the plastic and the edge of the hilt. So I may need to maneuver that in place a little bit. Needle nose pliers are a very, very small stapler, allows you to do that. The next thing that we have is we actually have the little ring that goes around it, and we have the nice little black piece that goes down around that as well. And that black piece was held in place with a screw, a long screw. Going to go down through that brass spacer, and it's a Phillips head. So I'm going to go over and grab my little repair size Phillips head, and if I got that lined up into the screw, down it will go and it will secure that little bit together. So basically I've got my nice little ring able to move around on there, and I've got my black piece in place. Okay, and you know, again, obsessive me, hey, test that out, see if that actually works. Put the battery pack on, give that a twist. Yep. So I know I've got that in fine position. Alright, next up is around this black thing, I need to find, there is a little hole on it. Let's see if we can actually get in a little bit closer so you can see what I'm talking about. Hopefully works pretty well on camera. Alright, so you can see that there is a little hole there, and that was the pin we actually had to push through. So when we had our orange knob, we had to line that up, and essentially that's what we ended up pushing through. And so we end up having to do that again. Okay. Alright, we zoom back out, see if we can actually do this, give you a little bit of a tip to doing that. So again, I've got that, I'll put that little post in my needle nose pliers, and actually one of the easiest ways to do this is if you can actually find the hole while it's not on there, my little cap, and I kind of just put it in and it'll kind of hold in place not too badly. I don't want it to go too deep because obviously I won't be able to get it on. But basically my next opportunity, or next step, is to kind of push it on. And while pushing down a little bit on there, you can move it back and forth while pushing down, and eventually it'll sort of click into place just a little bit when it hits the place where that black, where the hole in the black piece underneath is. So from there, it gets pretty easy just to take the nail punch. Since I don't have to punch it through this time, I used a bigger nail punch and just give it a couple of taps. Guess it's a little hard to see, everything's in the way. But we're just going to give it a couple of taps, and then eventually it goes right back into place where we want it to. And so again, I can just screw, the battery pack is in. Once the battery pack is in, I will screw the pommel back on with the battery pack in place. And yes, the knob does work. Let's just back that out a little bit so we get a little better room on that one. Very nice, so that's all working again for us. I can flip the thing over and I still have my CoverTech clip on there. So I'm going to put that on the hole on the back side, and again take my little Phillips head screwdriver and screw that back down into place. Okay. So all that's basically left for us to do now is go out, grab my tap bit, put that into the drill, and tap the inner blade holder now that it's firmly in position and we know where it needs to be. We'll tap that, and then I can put a machine screw through that to hold the blade holder in. And for that, I've basically got, once I've done that, I have my nice little blade plug that's going to go in there. Will be held secure by that. And that's basically it. So I'm not going to show that that piece. That's basically going to end this video with the complete assembly, because that's all that's left is just putting a tap hole and a screw in there. Part 3 of this conversion is going to go on to blades and blade diffusion techniques, and that will complete our 3-part series on converting a Darth Maul Master Replicas lightsaber.